In this lesson, we're going to learn how to graph natural base functions. So natural base functions look very, very similar to exponential functions. They just are a little bit different. So here what you're going to notice with the natural base function is that your b value is equal to e. So it's a natural base function because our base is that natural e number. The other thing you're going to notice is that what's changing in your exponent is you have a number in front of that x value. Since your base is not going to change in this particular function, the number in front of x in your exponent is going to change instead. So that's what we're looking at in this particular lesson. We have bases of e, and then we have a number in front of x in our exponent. Now, we have two different situations occurring depending on if r is positive or r is negative. So when r is greater than 0, which means r is positive. So when r is positive, let's do an example here so we can kind of see it. We have y is equal to, we can leave a as whatever we want, so say we have a times e to the power of 2x. Now what I notice here is that 2, that positive 2, is going to make this grow very, very quickly. So it's going to make it grow faster because 2 is larger than 1, and as a result, this is going to end up as an exponential growth situation. Now, if we flip this around and look at what happens when r is less than 0 or when r is negative, when that happens, we'll have something like y equals a times e to the power of, say, negative 2x. Now, in order to really interpret and figure out what's happening, let's write this with positive exponents. So we know to write it with positive exponents, we put it over 1. So we have a still up in our numerator because it has a positive exponent, but we have e in our denominator. You can also write it like this, a times 1 over e to the power of 2x. Now, if you think about what you know about exponents, when you have e in your denominator, what's going to happen is that over time, this number is going to be very, 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 very small. So when you have a negative r value, you're going to have a situation that is represented by exponential decay. So let's jump in and start graphing these. Now, in order to graph these, because e is an irrational number, you are going to need to use your calculator because it's not going to be easy to calculate otherwise. But just like before, let's calculate these by calculating a table of values. So we're going to start with x values -2, -1, 0, 1, and 2. And then we're simply going to plug these values for x into our equation and find the corresponding y value. Now remember, in order to find e on your calculator, you're going to probably need to press second, followed by the ln number, depending on your calculator. It might be in different locations, but that's typically where it can be found. So if I type in 3 seconds and then I find that e button, what you'll notice is it automatically puts it up into an exponent. That's because the natural base e is used when dealing with exponents and logarithms. So we're going to type in 0.5 and then multiply it by -2 and close off our exponent. So we get 1.10, and I'm just going to go to 2 decimal places here. Then from here, if I repeat this process and I do 3 to the power of 0.5 times -1, here we get 1.82 if I round. Then I move on and I do 0, and I find that it equals 3. Then I move on to 1, 4.95 approximately, and I move on to 2, which is about 8.15. So now I have my collection of values. I know this is an exponential graph, and I know that because this r value is positive. So notice it's not whether or not r is bigger than 1, it's whether or not r is positive. Because r is positive, I'm going to expect here to see exponential growth as I graph my equation. So if I begin to graph these points now, I have negative 2 comma 1.10, so that's about right there. Negative 2 comma 1.18, so that's about there. 0, 3, 1, 4.95, 2, 8.15. So I can see that as I expected, it is growing over time, shooting up there, and then it's going to get very, 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 very close to my x-axis, but not quite cross. So my domain here is going to be all real numbers. And then my range here is going to be y is greater than or equal to 0. So let's look at one more example here. So here we notice that our r value is a negative 2. So I'm already expecting that because my r value is a negative 2, because r is negative, I'm going to see exponential decay. So that's kind of what I'm expecting to see here, but we'll see what happens as we graph it. So I'm going to create my table of values here. So I have negative 2, negative 1, 0, 1, and 2. So now if I go to my calculator to utilize that e function, I do 1/2, which is 1 divided by 2. Then I do e to the power of negative 2 times my negative 2x value, which gives me approximately 27.30. So a little large, a little off my graph. Then if I have negative 1, I have 3.69. Then if I replace that negative 1 with 0, I end up with 0.5. Then if we move on to 1, we have 0.07. Gets very small very, very, very quickly. Then if we do 2, we have what looks like 0.01. So it starts off very large but gets very, very small. So here we can't plot that first point with negative 2, but we can do x is negative 1, y is about 3.69, so that goes there. Then we have 0, 0.5, and then we're already hitting these teeny tiny numbers down here. So I can see, if I connect the points for this exponential function, that this is in fact an exponential decay, as I expected, because the numbers are getting very, 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 very small as x approaches infinity. Now, the last thing I need to do is locate my domain and range. And I notice here that it goes forever to the left and right, so my domain is all real numbers. And then my range is going to be y is greater than 0, because it's using all of these y values above the x-axis, and then it's not quite touching the x-axis. It just gets very, 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 very close to it.